Rate of reaction. How can we express the rate of a reaction? Consider the reaction equation. Mercury plus chlorine gives mercury chloride. The rate of the reaction can be written in terms of the change in the concentration of the reactants as well as the change in the concentration of the products with time. So rate is equal to minus delta Hg concentration by delta T, which is equal to minus delta chlorine concentration by delta T, which is equal to plus delta concentration of HgCl2 by delta T. Consider the next equation. 2Hi gives H2 plus I2. The rate is equal to minus 1 by 2 delta Hi concentration divided by delta T, which is equal to plus delta hydrogen concentration by delta T, which is equal to plus delta iodine concentration by delta T. Since the rate of consumption of hydrogen iodide is twice the rate of formation of hydrogen or iodine, to make them equal, the term delta Hi concentration is divided by 2. Now consider the next reaction equation. 5Br minus plus BrO3 minus plus 6H plus gives 3Br2 plus 3H2O. Rate is equal to minus 1 by 5 delta bromide ion concentration by delta T, which is equal to minus delta BrO3 minus concentration divided by delta T, which is equal to minus 1 by 6 delta H plus ion concentration divided by delta T. It is also equal to 1 by 3 delta bromine concentration by delta T, which is equal to 1 by 3 delta concentration of water divided by delta T. The rate of a reaction depends on the concentration of reactants, temperature as well as catalyst. Consider the general reaction. A moles of A plus B moles of B gives C moles of C plus D moles of D. Rate is proportional to the concentration of A raised to X into concentration of B raised to Y. Therefore, rate will be equal to rate constant K into concentration of A raised to X into concentration of B raised to Y. How can we express the differential rate equation? The differential rate equation is given as minus dr by dt is equal to K into concentration of A raised to X into concentration of B raised to Y. Now consider the example. 2NO plus O2 gives 2NO2. The rate is given as equal to rate constant K into NO concentration squared into oxygen concentration. And what will be the differential rate equation? It will be equal to minus dr by dt is equal to K into NO squared into oxygen concentration. Now consider the next reaction. Chloroform plus Cl2 gives CCl4 plus HCl. The rate is equal to rate constant K into the concentration of chloroform into concentration of chlorine raised to half. The differential rate equation will be minus dr by dt is equal to rate constant K into chloroform concentration into chlorine concentration raised to half. In the first example, we find that the powers of the concentration of both the reactants are the same as their stoichiometric coefficients in the balanced chemical equation. Whereas in the second example, the power of the concentration of chlorine is given as half in the rate law expression, whereas its stoichiometric coefficient is 1 in the balanced chemical equation. That is, the power is different from the stoichiometric coefficient of chlorine. Therefore, we can conclude that the power of the concentration terms is not derived from the balanced chemical equation, but it is determined experimentally. That is, rate law expression is written after determining the powers of the concentration terms experimentally. Order of a reaction. Consider the rate law expression. Rate is equal to rate constant K into concentration of A raised to X into concentration of B raised to Y. The sum of the exponents X plus Y gives the order of the reaction. Therefore, order can be defined as the sum of the powers of the concentration of the reactants in the rate law expression. Order is an experimental quantity. It can have values like 0, 1, 2, 3 and even a fraction. Order is equal to 0 means it is a zero order reaction. Order is equal to 1 means it is a first order reaction. Order of a reaction is applicable to both elementary and complex reactions. Elementary reaction is a reaction which takes place in a single step. For complex reaction, order is given by the slowest step. If a reaction takes place in more than one step, that is for a complex reaction, the overall order of the reaction is given by the slowest step. For example, let the rate law expression for a reaction is given as rate is equal to rate constant K into concentration of A raised to half into concentration of B raised to 3 by 2. What will be the order equal to? We know that order is equal to x plus y, which is equal to 3 by 2 plus 1 by 2, that gives order as equal to 2. Now consider the next example. Let the rate law expression be given as rate is equal to rate constant K into concentration of A raised to 3 by 2 into concentration of B raised to minus 1. Here the order will be equal to x plus y, which is equal to 3 by 2 plus minus 1, that gives order as equal to half. It is a half order reaction.